Hello and welcome back to the Data Unite channel. Today we are going to understand how to implement the support vector classifier machine learning model on a real-world dataset where we are interested to predict whether a person will open a bank account if the bank targets that person during this marketing campaign. As you can see, I have already imported the necessary frameworks that we're going to use for this exercise, which are pandas, matplotlib, that's going to be used for graphing, pandas for all the logic that we are going to use for creating our datasets. I'm going to import also the library preprocessing for the label encoding. I'm going to use also standard scaler in order to normalize the values of the features. Train and test split from the sklearn library, which will be used to split our dataset into training and testing datasets. Then also, since we're using the K-nearest neighbors model, I imported also K-nearest neighbors classifier, and also in order to see the performance of our model classification report. So the first thing is to import our dataset. So for that we will use pandas read CSV. And I'm gonna use the banking CSV that we used before for the other classification problems. Now let's see also the first 5 rows of the data. So as we can see, we have 21 columns and 5 rows, and we have different types of data types into our dataset. So we have string, we have integer, we have float, and so on. Our dependent variable, which is the one that we want to predict, is the y variable. Now let's see also the shape. So we have shape. Okay, so we have 41,188 rows, and let's print also the columns. Okay, these are the columns, but we are gonna use this one as a dependent variable. This is the one that is gonna be predicted or classified. Now let's do some pre-processing. So I'm gonna put here step 1. Make it a markdown. Let's see if we have some null values. So df dot is now sum. Okay, we have all of the features don't have missing values, so we are good to go. Then we will see if we have some duplicates. So we do df dot duplicated any. So if there is any duplicate, yeah, it says that we have. So it would be good if we drop them, because if we have duplicates, that will impact on our prediction at the end. So let's drop them. Okay, and now we have 41,176, which means that we dropped 12 rows, which were duplicates. Okay, good. I'm gonna save this into the data frame. Now the next step is to encode our columns that are categorical, because as we know, the K-nearest neighbor algorithm does not accept string values, so we need to transform them into numerical values. And for that, let's see first which columns are numerical and which are string. So all of the object columns in our case contain data which is textual or string. So in our case, the easiest ways to split this data or to encode our data is by splitting our features into numerical and object. So I'm gonna do the following way: numerical df dot select object, and categorical will be that will include the object. Include. Okay. Let's see now the data. So numerical dot head. Okay, this is the numerical and the categorical. Okay, as we can see, we have split correctly all our data. So we have into numerical all the features that have numerical data, and in categorical all the features that have string data. Okay, now the next step is to apply the label encoder, the label encoding, and for that we need first to initialize our label encoder, which is done the following way: preprocessing encoder, and then I'm gonna call this label encoder and apply it to our categorical data frame in this case. So I'm gonna name our data frame as LE categorical, apply, fit and transform. Okay, so now let's see our new categorical data frame. Okay, so from string we have changed to numerical. I'm using label encoder because I want to keep my data set with the same dimensions. This might lead to some bias because with the numbering, sometimes our algorithms are giving some preference to the values that have smaller numbers. For example, 1 will be considered as more important than 9 in this case. But in order to avoid this, it might be better to use one-hot encoding. But if we have a lot of string, so a lot of categories into one feature, and then we have more features with many categories inside, then this dataset would explode. So instead of having how many? 4, 6, 8, 10 features, we will have maybe 100, maybe even more. So this will be an issue, because then it will be more difficult for us to understand what's happening, and it might also take to the algorithm to input more time into processing this dataset. So I chose this way. It's not that incorrect, but also it can be improved. But for the purposes of this video, this should work fine. So since we transformed our categorical features into numerical values, now let's concatenate this final data frame with the numerical data frame. So that we have all the values into one dataset. And with this, we implemented our model on a real-world dataset. And as you can see, it is not that complicated, but it is important to know how to prepare the dataset so that can be used by the model and at the end to understand and interpret our results. So thank you very much for following this video until the end, and I hope you liked it. See you in the next one. Bye bye.